This video is for graphing logarithmic functions. So the logarithmic parent function is f of x equals log x. Okay, so logarithmic function is the inverse of an exponential function. So using your graphing calculator, sketch the following graphs. So log of x, if we look at that one, and we do log, and this would be 10 x. We can kind of see what it looks like here. And then if we do the other one that's on here, which is, so you can kind of see 10 to the x, 10 to the x, you can see it's the opposite. And we will talk more about inverses in the next chapter. So the logarithm of x does something like this, and then 10 to the x does this. Alright, so because you can only graph base 10 log on your calculator, you will need to use the inverse exponential function, then invert the values from the table to graph the logarithmic function. Okay, so here's what that means. We need to rewrite log 2 of the x. So hang on real quick. So what that means, if you're using a calculator, that will not do this. Your calculator will do this. It will work. So I'm just going to show you what you would do. You would take this function and change it to exponential form, which would be 2 to the x. Okay? You'd make you a table of values. So -2, -1, 0, 1, and 2. 0.25, 0.5, 1, 2, and 4. And you can invert these values. So to find the inverse of a function, so the inverse would be what we started with, log 2 to the x. All I have to do is flip the x and y values. The y's become the x's become the y's, and then I can graph this. So 1, 0, 2, 1, 4, 2, and I can graph this. Okay? So our domain, x has to be greater than 0. So we cannot take the log of a negative value. So the x's are always going to be positive on logarithmic functions. The range can be all real numbers. It will go through every single y, infinity to negative infinity. So as x approaches infinity, y approaches infinity. As x approaches 0, f of x, that's this way, approaches negative infinity. The x-intercept is 1, 0. And then our asymptote here, so if you remember with exponential functions, the asymptote was y equals 0. Here, it's x equals 0. Okay, so again, your calculator, you're kind of blessed because of the calculator you have. You don't have to do all this. So we can just go in and put our logarithm in. So this is 1/3 down here to the x, and then we can pull the table up and get our values. So our table here, x comma y, let's just start with, let's do nice pretty numbers. So 0 is undefined. So 1 is a 0, 3 is a -1, 9 is a -2, and I think that's all we're going to get that's going to fit on this. So 1, 0, 1, 2, 3, -1, and then 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, -2, something like that. Again, we can look at our graph to kind of see what it looks like visually to help us, just understanding that it's never going to cross that y-axis. So the domain, x has to be greater than 0. The range is all real numbers. as x approaches 0. So as x approaches 0 here, that's this direction. here, y or f of x is going to approach infinity. And as x approaches infinity, that's going this direction, f of x is going to approach negative infinity. The x-intercept is 1, 0, and the asymptote is, again, x equals 0. Okay. The next page, practice this some more. So we can graph this one. So we've got log 4 to the x minus, my goodness, minus 1. And then we can pull up the table. We just want, again, we want to try to stick with nice and pretty values here. So we've got 2 and 0, 3 and 0.5, 5 and 1, and that may be 9 and 1.5. That one's not too bad to do. Then we can graph. So 2, 0, 3 is 0.5, 1, 2, 3, 4, 5, and 1, 6, 7, 8, 9, and 1.5. Again, looking at our graph, kind of seeing what it looks like, we can see that it does something like this. So the domain here is x has to be greater than 1. And one way that you can tell that from the table, see how we get this undefined value right here at 1? That kind of lets us know where that asymptote is. So the range is all real numbers. As x approaches infinity, f of x approaches infinity. As x approaches 1, f of x approaches negative infinity. The x-intercept is 2, 0. And the asymptote, so this is the asymptote, I went a little over it, is x equals 1. So in the logarithm, if we've got something adding or subtracting to the x here, it's going to change the asymptote. All right, on this next one here, we've got log 3, and then we've got x minus 2. So let's see, we may not need to put that x minus 2 in parentheses. Yeah, I don't think that x minus 2 needs to be in parentheses. So let's do this. Let's take log of 3, and then let's take these. So we're going to put the x in the parentheses, but then the minus 2 comes after. Okay, so that's the difference between these two. The minus 1 is in parentheses. The minus 2 is not in parentheses. So really watch those. And then let's make a table. And let's see. So at 0, we're undefined. X and y. So we've got 1 and negative 2, 3 and negative 1, 9 and 0. So 1 and negative 2, 3 and negative 1, and then we've got 9 and 0. And so this thing is going to do something kind of like this. Didn't graph that very well. So the domain here is x is greater than 0. The range is still all real numbers. As x approaches 0, f of x approaches infinity. Oh, that should have been reversed. Sorry. As x approaches this way, infinity, f of x is going to approach infinity. And then as x approaches 0, f of x is going to approach negative infinity. Our x-intercept here is 9, 0. And then our asymptote again is here at x equals 0. Okay, now we've got lots to type in on one. So we've got log, and then this is 1/2, and then we've got x plus 9 in the parentheses, and then plus 4 outside. So pull up the table, and let's see, there's some decent looking points. So let's just go with what we've got there. X and y, -5 and 2. Oh, we've got some better ones. -8 and 4, -7 and 3. And I don't know if we've got anything else. Let's see. -1 and 1. Sorry, my table's out of order there. So again, you can see our undefined value here at -9. That's going to be our asymptote. So if I graph this, -5, 1, 2, 3, 4, 5, -2, and then 6, 7, or sorry, that should be +2, 7 and 3, 8 and 4, and then -1 and 1. So our graph is going to do something like this. So it looks completely different than anything else we've graphed. So here, x is going to have to be greater than -9. Remember, that was the undefined value. Range is still all real numbers. So here, as x approaches -9, f of x is going to approach infinity. As x approaches infinity, f of x is going to approach -infinity. My y-intercept, so for this one, see if we can find a y-intercept on here. There it is, 7, 0. 7, 0. And then the asymptote, didn't do very good drawing this one either, is there. So this line should kind of shoot up this way as x equals -9. All right, and one last one here. So we've got log 5 x minus 2, and then outside we've got a +1. So we're going to pull the table up here. So there's our undefined value at 2. Okay, so that's going to be our asymptote. So we've got, let's see, 3 and 1, 7 and 2. I wonder what our x-intercept is. So let's find our x-intercept by using some of these graphing tools. So what I can do is menu 6, 1 to find the 0, and that will pull my x-intercept, so 2.2, 0. If I graph this, 1, 2, 3, 1, and so the x-intercept is in there somewhere. That's 3, 4, 5, 6, 7. So this one is going to go this way and then go straight down this way. So our asymptote is at 2. So my domain, x has got to be greater than 2. Range is all real numbers. As x approaches infinity, f of x approaches infinity. As x approaches 2, f of x approaches -infinity. Our x-intercept is 2.2, 0, and our asymptote is x equals 2.